It's an exciting day for mathematicians at the University of Chicago.
They have received a beautiful gift with a complicated story. We'll try to explain how this works. It's a Gomboc sculpture.
Some inventions seem to break every rule of science, bending reality in ways that leave more questions than answers, pushing the limits of what we thought was possible. From gravity-defying machines to objects that challenge time and space, these mind-bending breakthroughs are as astonishing as they are controversial. What if the impossible wasn't just a dream, but a reality built by human hands? Join us as we explore these inventions that defy the laws of physics. Dipping bare hands in molten lead. If someone claimed they could dip a bare hand into a pot of molten lead and pull it out unharmed, it might sound like a joke. Yet this seemingly dangerous feat is possible thanks to a fascinating quirk of physics called the Leidenfrost effect. Molten lead isn't as scorching as one might think. It melts at 327.5 degrees Celsius, far cooler than molten iron or steel. However, it's still hot enough to cause severe burns in an instant. The key to surviving this fiery dip lies in something unexpectedly simple.
This is a pan of molten lead, and you are going to be amazed at what I'm going to do with it.
Water. Wetting a hand and quickly plunging it into molten lead causes the extreme heat to instantly vaporize the water.
Get my hands wet, shake off the excess drops, and then in and out. You just got to do it fairly fast.
Forming a protective layer of steam that shields the skin from the scorching metal. The vapor barrier works like an invisible glove, preventing the lead from directly touching the skin for a brief moment. This phenomenon was discovered in 1756 by German doctor Johann Gottlob Leidenfrost, who noticed that water droplets would dance and hover above a hot surface instead of immediately evaporating. The same principle explains why water droplets skitter across a very hot skillet, or why liquid nitrogen appears to float when spilled. But don't try this at home. The protection lasts for only milliseconds, and any mistake in timing or technique could result in severe burns. Scientists who demonstrate this effect are highly trained and take careful precautions. They typically dip their fingers for less than half a second, as any longer could break through the protective steam barrier. The Leidenfrost effect has practical applications beyond dramatic demonstrations. It helps engineers design better cooling systems for nuclear reactors, improve fire protection gear, and even develop new methods for treating certain medical conditions. What looks like a dangerous party trick reveals one of nature's clever ways of protecting against extreme heat. The Perpetual Motion Quest. Perpetual motion machines have long captured the imagination of inventors. The idea behind these machines is simple but bold. Once set in motion, they would continue to move forever without stopping.
Perpetual motion is impossible, but if it's at all possible.
If this could be achieved, it would solve many problems related to energy loss in mechanical systems, creating machines that never run out of power. This dream of endless energy has fascinated scientists for centuries. The first notable attempt at creating a perpetual motion machine dates back to the 17th century. In one of the earliest examples, an inventor named Robert Flood designed a water screw in 1618. The machine was meant to rotate a millstone continuously by using the same water that powered it. The idea was that the water would be pumped back to its original tank, allowing it to run the machine again and again without needing a fresh supply. This seemed like a clever way to make a machine that could run forever. Another example came with the creation of the Macintosh wheel, which used magnets to make it spin. The magnets placed in a certain arrangement made the wheel appear to rotate without ever slowing down.
Cheat the center of gravity so it's always on one side, constantly unbalanced in the same direction.
With modern technology, such machines can now be made using powerful magnets like neodymium magnets, which can keep spinning for years. However, even though the wheel seems to move forever, it is still dependent on the magnets losing their strength over time, causing the machine to eventually stop. Despite these intriguing designs, perpetual motion machines cannot truly work. They break two important laws of physics known as the laws of thermodynamics. The first law states that energy cannot be created from nothing. It has to come from somewhere. The second law explains that every system, no matter how well made, will eventually lose energy and move toward a state of disorder known as entropy. This means that mechanical systems will always eventually stop functioning, no matter how carefully designed. For example, the water screw would eventually lose energy due to friction, which slows down the movement of parts and wastes energy as heat. In the case of the Macintosh wheel, Even the strongest magnets would lose their magnetic force over time. This shows that while perpetual motion machines are fascinating and imaginative, they are impossible because they ignore these fundamental laws of nature. Though these machines may seem to work for a while, true perpetual motion remains a dream that cannot be realized. And that's all for today. Thanks for watching. Vacuum power lifting cars. When the Mythbusters team announced they would try to lift a car with a vacuum cleaner, many people laughed. After all, most vacuum cleaners can barely lift a 5-pound weight with their standard attachments.
Always wanted to test it. The myth is that a standard household vacuum cleaner.
But the team understood something crucial about the physics of suction. Its power grows dramatically when spread across a larger area. The science behind this feat lies in understanding air pressure. A vacuum cleaner works by removing air from an enclosed space, creating an area of low pressure. The surrounding air pressure then pushes down on the surface, creating suction. The stronger the pressure difference and the larger the area, the more lifting power you get. The team built 40 custom suction cups and connected them all to a single powerful vacuum cleaner. Each cup was carefully designed to create an airtight seal against the car's surface. When they turned on the vacuum, the combined force of all these suction points working together generated enough lifting power to raise the car steadily into the air. This principle explains why a small suction cup on a shower caddy can hold several bottles of shampoo, while a large suction cup can support much more weight. The lifting force increases directly with the surface area, doubles the area, and doubles the lifting power. Some mathematicians have calculated that with a perfect seal and a large enough suction cup, even human lung power could theoretically lift a car. While this would be practically impossible to achieve, the math shows how powerful suction can be when properly harnessed. Today, this same principle is used in industrial lifting equipment, helping factories move heavy materials without complex mechanical systems.
So far here, all 3 boxes are saying, hell yeah, I can lift that car.
Vacuum lifting has become especially important in handling delicate materials like glass panels or electronic components, where traditional grips might cause damage. The vacuum car lift experiment proved that sometimes the most ordinary tools can achieve extraordinary results when we understand and apply the physics behind them correctly. The mind-bending warp drive engine. Folding paper can bring distant points together, and scientists aim to do the same with space. As humanity dreams of reaching distant stars, our current rockets face a frustrating problem. They're just too slow. Even traveling at 84,000 kilometers per hour, it would take 54,000 years to reach our closest neighboring star system. But what if we could create a shortcut through space itself? That's where the warp drive comes in.
For decades, faster-than-light travel, often referred to as warp drive, has been one of the most captivating concepts in science fiction.
A revolutionary concept that sounds like science fiction, but is slowly inching toward reality. Instead of moving through space like a traditional spacecraft, a warp drive would create a bubble that bends the fabric of space-time around it. Think of it like a surfer riding a wave, except this wave is made of compressed time and space. The concept works by squeezing space in front of the spacecraft while stretching it behind, creating a cosmic shortcut that could dramatically reduce travel time to distant stars. The traditional rocket fuel wouldn't be needed at all. The spacecraft would essentially surf through space-time, carried by the warped bubble around it. While this might sound like pure fantasy, both NASA and Chinese space agencies have made intriguing discoveries. In recent experiments, they've observed mysterious movements in special chambers where microwaves bounce around. Scientists still can't fully explain these results, but they hint at possibilities we never thought existed. One of the most promising destinations for this technology would be Proxima b, an exoplanet that might be similar to Earth. With conventional spacecraft, reaching it would take longer than all of human civilization has existed. But with a working warp drive, the journey could potentially be shortened to just decades. The challenge now lies in understanding exactly how these early experiments work, and whether they can be scaled up from tiny movements in a laboratory to something that could transport humans across the stars. While we're still far from building an actual warp drive, these first steps show us that it is possible. The self-correcting Gomboc. Picture a toy that, no matter how it is placed down, always rights itself to stand in the same position. It sounds impossible, right? That is Gomboc, a remarkable object that seems to have a mind of its own yet operates purely through its unique shape. The story of this self-righting marvel begins with a mathematical challenge. In 1995, Mathematician Vladimir Arnold wondered if there could be an object that would always return to one specific position, like a weighted toy, but without any weights inside.
Even if you put it on its side, it will always right itself. Picture a tortoise that's been placed on its back.
For 11 years, this puzzle stumped the brightest minds until two Hungarian engineers, Peter Varkonyi and Gabor Domokos, finally cracked the code in 2006. What makes the Gomboc truly special is that it's completely uniform inside, with no hidden weights, no special materials, just one solid piece. Its secret lies entirely in its carefully calculated shape, which features exactly one stable point where it wants to rest, and one unstable point where it can balance briefly before tipping over. It's like a roly-poly toy but without the weighted bottom. Nature, it turns out, discovered this principle long before humans did. Indian star tortoises have shells shaped remarkably similar to the Gomboc, helping them flip back over if they end up on their backs. Some rocks naturally weather into Gomboc-like shapes over thousands of years. Creating a perfect Gomboc requires incredible precision. Even a tiny error of less than 1/10 of a millimeter can ruin its self-righting ability. Each one must be crafted with advanced manufacturing techniques and carefully tested to ensure it works properly. That's why genuine Gombocs can cost over $1,000. Scientists continue studying the Gomboc because it helps them understand stability and balance in nature. From improving robot designs to understanding how animals move, this seemingly simple shape has sparked discoveries across multiple fields of science. While the Gomboc defies expectations through pure shape, another physical phenomenon allows humans to perform what seems like an impossible magic trick. Come along for this, as we can now safely dip hands into molten metal. The M-Drive space thruster. When NASA announced they had tested an engine that seemed to work without fuel, the scientific world held its breath.
However, back in 2014, NASA did announce that they had made a working example of this.
The M-Drive, a copper cone that supposedly could push spacecraft through space using only microwaves, appeared to break one of physics' most fundamental rules, Newton's third law of motion. When riding a bicycle, pushing the pedals propels the bike forward by pushing against something. Newton's law explains this principle. Every action has an equal and opposite reaction. The M-Drive, however, claimed to produce thrust without pushing against anything, similar to attempting to move a bike by merely imagining pedaling. The device looked deceptively simple, a sealed metal cone that bounced microwaves back and forth inside. According to its British inventor Roger Scheuer, these bouncing microwaves could somehow create enough force to push a spacecraft through space. If true, this would revolutionize space travel. Spacecraft could travel for years without carrying heavy fuel tanks, making deep space exploration much more practical. In 2016, NASA's EagleWorks laboratory published results claiming they had measured a tiny amount of thrust from their M-Drive tests. The space community buzzed with excitement. Could this really be possible? Had we discovered a loophole in the laws of physics? But science works through careful verification. German scientists at Dresden University decided to build their own M-Drive to check NASA's results. They created an extremely sensitive testing setup that could detect even the smallest forces. What they found solved the mystery. The apparent thrust wasn't coming from the M-Drive at all, but from the interaction between the power cables and Earth's magnetic field. While the M-Drive didn't end up breaking physics, it reminded us of something important. Even when something seems impossible, it's worth testing properly. Many great discoveries have come from investigating things that initially seemed to break the rules. The M-Drive may not have revolutionized space travel, but it showed how rigorous scientific testing helps us separate fact from wishful thinking. The fan-powered sailboat paradox. Picture a sailboat with something unusual on board, a giant fan blowing air at its own sail. Logic suggests this shouldn't work. After all, it seems like trying to move forward by pushing against oneself. Yet, this unusual experiment shows how physics can sometimes lead to unexpected and fascinating outcomes. Normally, sailboats harness the wind's power as it blows across their sails from behind or the side. But in this unusual setup tested by the Mythbusters team, they placed a powerful fan on the boat's deck, pointing it straight at the sail in front. At first glance, this seems completely backward. The fan is pulling air from behind the boat and pushing it forward, which should make the boat move backward, right? But something else happens. When they turn on the fan, the boat moves forward.
The team has seemingly contradicted Newtonian physics. It's working. They're blowing their own sail.
The secret lies in how the air interacts with the sail. When the fan's airstream hits the curved sail, it doesn't just stop, it bounces off in multiple directions. Some of this redirected air shoots backward, and according to Newton's third law of motion, this backwardly moving air pushes the boat forward. It's like throwing a basketball against a wall. When the ball bounces back, it pushes the hands backward. The sail works similarly, bouncing the fan's air backward and generating a forward push. This principle is similar to how jet engines function, using redirected air to create thrust. The Mythbusters team discovered that while this setup does work, it's not very efficient. The same fan pointing backward without using the sail would push the boat much faster, because all the air would be moving in one direction. This peculiar boat also reminds us that nature's laws, while unbreakable, can work in unexpected ways. While the fan-powered sailboat plays tricks with air movement, another inventor found a way to make water itself appear to defy gravity's eternal pull: the uphill water fountain. When visitors arrived at the 2003 Chelsea Garden Show in England, they couldn't believe their eyes. There, in plain sight, was water flowing uphill, seemingly breaking one of nature's most fundamental rules. The creator of this mind-bending illusion was none other than James Dyson, the same inventor who revolutionized vacuum cleaners and hand dryers. The fountain appeared to be a simple stream of water traveling up a slanted surface, like a river flowing backward. People stood mesmerized, trying to figure out how water could ignore gravity's downward pull. Some wondered if powerful pumps were involved, while others suspected magnetic water might be the secret. The truth behind this watery wonder was both simpler and more clever than anyone guessed. Dyson had created a unique structure using two sheets of transparent plastic with a narrow space between them. Inside this hidden channel, pressurized water was pumped upward, but the real genius was a thin layer of water flowing down the outside of the structure. This combination created a perfect illusion. The eye couldn't distinguish between the internal and external water flow, making it appear as if all the water was traveling uphill. The installation demonstrated Dyson's talent for turning engineering principles into artistic displays, similar to his bagless vacuum cleaners that made invisible air movements visible through clear plastic chambers. This fountain made invisible water pressure visible through clever design. The uphill water fountain may appear to be just a clever trick, but it offers an important lesson about science and perception. What's visible isn't always what's happening. Sometimes, understanding requires a deeper look beneath the surface. This principle helps engineers and scientists solve all sorts of real-world problems, from designing better water systems to creating more efficient ways to move liquids in industrial processes. Square wheels that actually work. The wheel is often celebrated as humanity's greatest invention, that perfect circle that made transportation smooth and efficient. So why would anyone try to make wheels square? The Mythbusters team took on this seemingly ridiculous challenge and discovered something remarkable about geometry and motion. At first, 4 square wheels were attached to a vehicle, all aligned at the same angle. The result was predictably disastrous. The car bounced violently, threatened to shake apart, and quickly broke its axles. However, a clever adjustment was made. Each wheel was offset by 22.5 degrees from its neighbors. This small change made all the difference. When the vehicle moved fast enough, it achieved a surprisingly smooth ride. The secret lies in the timing of when each corner hits the ground. With the wheels offset, one corner would contact the surface just as another was lifting off, creating a more continuous rolling motion instead of the harsh jumps you'd expect.
Testing the myth that square wheels will give you a smooth ride.
The physics behind this works similarly to how a cat always lands on its feet. It's all about timing and positioning. Each square wheel acts like a series of small steps rather than one big bump. When properly spaced, these steps flow into each other, smoothing out the ride. The team didn't stop there. They tested these unusual wheels on hills, wondering if square edges might give better grip than round ones. While this didn't prove advantageous, the experiment revealed fascinating insights about friction and momentum in unusual situations.
The truck's going to have to be really heavy duty. It's going to have to be 4-wheel drive and have a big torquey engine in it.
The square wheel discovery has practical applications beyond unusual vehicles. Engineers use similar principles when designing robot legs, mining equipment, and specialized machinery that needs to handle rough terrain. Sometimes what seems like a worse design can actually solve problems in unexpected ways. While square wheels won't replace traditional round ones anytime soon, they remind us that innovation often comes from questioning basic assumptions. Sometimes the wrong shape might be exactly right for the job. One-sided bulletproof glass. Regular bulletproof glass has a simple job: stop bullets from both directions. But military engineers faced a tricky problem. How could they protect soldiers while still letting them shoot back? The solution was one-sided bulletproof glass, a clever innovation that blocks incoming bullets while allowing outgoing shots to pass through. Traditional bulletproof glass works by sandwiching a tough layer of polycarbonate plastic between sheets of glass. When a bullet strikes, the layers work together to absorb and spread out the impact force, preventing the bullet from breaking through. However, this protection works both ways, making it impossible for defenders to return fire effectively. The one-sided variant uses a sophisticated layering system that changes how the glass responds to impacts from different directions. From the protected side, the layers compress and strengthen when struck, stopping incoming bullets cold. But from the shooting side, the layers interact differently, allowing bullets to punch through while maintaining the structure's integrity. This technology has transformed military vehicle design. Previously, soldiers in armored vehicles had to choose between complete protection or the ability to shoot back. With one-sided bulletproof glass, they can maintain both defensive and offensive capabilities simultaneously. The glass requires extremely precise manufacturing. Each layer must be exactly the right thickness, and they must be bonded together under carefully controlled conditions. The outer layer is typically treated with special coatings that help prevent dangerous fragments that can spray inward when the glass is struck. Scientists continue developing improvements to this technology. Modern versions can stop higher caliber rounds, resist repeated impacts better, and maintain better visibility. Some newer designs even incorporate special materials that help reduce the glass's weight while maintaining its protective properties. While one-sided bulletproof glass might seem to defy logic, it demonstrates how understanding and controlling the physics of materials can create solutions that appear impossible. It's a perfect example of how engineering can solve complex problems by working with, rather than against, the laws of physics. The gun that shot around corners. During World War II, weapons designers faced a dangerous challenge. Soldiers needed to fire from behind cover without exposing themselves to enemy fire. The solution they developed was the Krumlauf.
In 1943, Germany started researching and developing the Krumlauf, or in English, curved barrel.
An attachment that allowed rifles to shoot around corners, an idea that seemed to break the basic rules of how bullets travel. The Krumlauf was essentially a curved barrel attachment for the Sturmgewehr 44 rifle. The Germans engineered special curved tubes with precisely placed holes along the bend. These holes managed the explosive gases that propelled the bullet, helping guide it around the curve instead of simply crashing into the barrel wall. The science behind this weapon was remarkably complex. Bullets typically travel at 1,000 feet per second, faster than 3 times the speed of sound. Making such a fast-moving object turn required incredible precision in the barrel's design. The holes had to be exactly the right size and position to vent the gases properly, or the whole system would fail. Different versions were developed for various purposes. The most common had a 30-degree bend, but some variants could turn bullets up to 70 degrees. One version was even designed to shoot directly backward, causing the rifle to recoil forward instead of backward, a truly bizarre effect that confused everyone who witnessed it. However, the Krumlauf had serious limitations. The curved barrel typically lasted only a few hundred shots before wearing out. Many bullets would break apart while turning, creating a spray of fragments instead of a single projectile. This made the weapon very inaccurate beyond close range. Today, modern armies have developed safer alternatives. The Israeli corner-shot weapon system uses cameras and pivoting mechanisms to let soldiers see and shoot around corners without bending bullets at all. While the Krumlauf ultimately proved impractical, it demonstrated how creative engineering could push the boundaries of what seemed possible, even if the results weren't always practical. The Limbo endless spinning top. Remember the spinning top from the movie Inception that kept spinning endlessly in dreams? A real company created something nearly as magical, a top called Limbo that can spin for an astonishing 27 hours, 9 minutes, and 24 seconds, earning itself a Guinness World Record. Regular spinning tops typically last for a few minutes at best before wobbling and falling over. They battle against friction from the air and their point of contact with the surface, gradually losing energy until gravity wins. But Limbo seems to break these natural limits, spinning for longer than a full day. The secret behind this extraordinary feat lies hidden within the top's sleek exterior. Inside sits a masterpiece of modern engineering, an asymmetric flywheel motor that maintains the spin, a sophisticated motion sensor that monitors every tiny movement, and a rechargeable battery powering it all. At the heart of the system, a miniature computer chip makes dozens of tiny adjustments each second, keeping the top perfectly balanced. When the top begins to wobble even slightly, the sensors detect this movement immediately. The computer processes this information and signals the motor to make precise corrections, much like how a tightrope walker constantly shifts their weight to stay balanced. These adjustments happen so quickly and smoothly that the top appears to spin naturally. The technology in Limbo builds on principles used in spacecraft stabilization systems and high-tech gyroscopes. The same basic concept helps keep satellites properly oriented in space and stabilizes camera gimbals for smooth video recording. While Limbo doesn't truly defy physics, it still needs energy input from its battery. It demonstrates how modern technology can create seemingly impossible effects. The top has become a popular desk toy in offices and schools, sparking conversations about physics, engineering, and the intersection of simple toys with complex technology. This marriage of ancient toys and modern engineering shows how classic objects can be reimagined with new technology, creating something that appears to bend the rules of nature while actually working within them. While Limbo uses advanced technology to keep a tiny top spinning, another experiment proved that a household vacuum cleaner could perform an even more impressive feat. Driving on water. You've probably seen water striders, those insects that walk on water's surface as if it were solid ground. As it turns out, regular motorcycles and cars can perform a similar feat, at least for a brief moment, thanks to some fascinating physics. A standard motorcycle, without any special modifications, can actually travel several hundred feet across water. The key is maintaining extremely high speed.
This time he's upping the speed to 80,
which creates a peculiar interaction between the vehicle and the water's surface tension. The motorcycle's tires spin rapidly, throwing water backward and creating a lifting force, similar to how a speedboat's hull rises above the water at high speeds. This phenomenon relies on the same principles that allow stones to skip across a pond. When an object hits water at the right speed and angle, it can briefly bounce off the surface before gravity pulls it down. The faster the object moves, the more likely it is to skip instead of sink. Cars can achieve a similar effect, though not as dramatically as motorcycles. A car moving at high speed can skip across a short stretch of water, almost like a giant stone. The vehicle's momentum and the way its tires interact with the water create a brief window where the car literally bounces across the surface rather than sinking. Surface tension plays a crucial role in this process. Water molecules hold tightly to each other, creating a kind of invisible skin on the water's surface. While this force is usually too weak to support heavy objects, the combination of high speed and the right angle can temporarily overcome water's tendency to let things sink. Professional drivers have demonstrated this effect under controlled conditions, but it's incredibly dangerous to attempt. The slightest miscalculation in speed or angle can lead to disaster, as water resistance can suddenly grab the vehicle and bring it to an abrupt stop. These demonstrations reveal how forces that seem too weak to matter in everyday life can create remarkable effects under the right conditions. Space elevator dreams. The idea of a space elevator sounds like something out of science fiction, but it's a concept that could revolutionize how we travel to space. Right now, getting to space requires rockets, which are expensive and use up a lot of energy. For example, launching a rocket like the one from SpaceX uses the same amount of energy as 4 million metric tons of TNT. That's a lot of power, but scientists and engineers are looking for a better way. One idea they're exploring is the space elevator. This would be an enormous structure, like a giant cable, stretching from the surface of Earth into space. The idea is simple. Rather than using rockets, we could send cargo, satellites, and even people up to space by riding this elevator. It would be much cheaper and more efficient. However, building this space elevator is not easy. The cable would have to be incredibly strong and flexible. It would need to bend with the Earth's rotation as it moves, but it also has to be strong enough to hold a load that could reach space, which is about 100 kilometers above the Earth's surface. To put that in perspective, Mount Everest is only about 8 kilometers tall. In the past, scientists thought carbon nanotubes could provide the strength needed for the elevator, but new research suggests that diamond nanothreads might be the better material. These tiny, super strong threads could make the elevator strong enough to hold up to the weight of the cable and whatever it carries. The most exciting part is that a giant construction company in Japan believes we could have the technology to build a space elevator by the year 2050. While there are still many challenges to overcome, this futuristic idea is inching closer to becoming a reality, and it could change how we access space forever.